In this video, we're going to create a top-down movement script using the new input system in Unity. If you copy the 2D template or using the class version Unity, then this is the input system you're supposed to use. The first thing we're going to do is make a character to put the script on so we can test it out. So I'm going to click plus, 2D object, sprites, and then we'll do a square. Now, I might go fast through some menus that I think people are more experienced with. If you need to, you can always slow down the video or rewind or stop it completely. And if I'm going too slow, you can always speed up or skip through, although I recommend not doing that because you might miss some good explanations. We got a square here. I'm going to rename it to player, and then we're going to create a script for this guy. There's a few ways you can create a script. I recommend doing it through the assets menu down here, because one way is by clicking add component and typing in the name of the script you want to create, like top-down movement, for example. But this is always going to create it just in the assets folder. And that's a little problematic because 99% of the time, you should actually have a folder called scripts, and all your scripts should go in there. However, if you do the add component method of making a new component, it's not going to put it in that scripts folder. On top of that, if you're working with a team, you might have different folders for each member of the team, and this is going to make it impossible to put it there as well. So I'm going to actually create a scripts folder like I already did, and then inside the scripts folder, I'm going to right click, create mono behavior script, and I'm going to call this top-down movement. It is vital that you do not put any spaces in the name of your script. That could break everything. I'm going to go ahead and open up the script after it finishes loading. I already have Visual Studio open because I wanted to make this part quicker, but again, you can always pause or rewind or anything. Here we have the void start. Any code you write in here is going to happen only once when the game starts. It's good for initializing or setting up your game. For example, you might want to teleport the player back to the starting position, or you might want to reset the player's health. You'd only want to do that one time at the beginning of your game. Then we have the void update. Everything here happens every single frame over and over again. This is good for things that should happen during the duration of the game, like animations or checking for player input or updating physics. We have this script. We're actually going to go back now because I just want to set that up. The player needs, first of all, needs the script that we just made. So there's a few ways you can add it on, but I'm just going to say drag the script onto the player. And then we're going to add a component called player input, which is part of the input system. So this is a new warning that I've actually never seen before, but we're going to completely ignore that because I think it's just fine. Anyways, so under here it says behavior send messages. We're going to switch that to invoke Unity events, and I'll explain why in a little bit. But first, I want to actually open up the input system so we can inspect and see what's going on here. So the input system has a bunch of different inputs, and then it has actions. So these are action maps. These are things you can control with an input device. For example, I can control the player and I can control the UI. Each action map has multiple actions. That's things that control can do. For example, the player can move, it can look, it can attack, it can interact, it can crouch, it can jump. Previous and next is counter UI related, so I'll ignore that. And it can sprint. And the UI has a bunch of UI related things. Now, again, every action map has multiple actions, and every action has multiple ways to do that action. So if I click the little drop down arrow, you'll see there's 4 ways we can move. The left stick of a gamepad, the WASD of a keyboard, the 2D axis of an XR controller, which is like VR stuff, or AR, and the stick of a joystick. If you go into WASD, you'll actually see there's 8 of them. W, S, A, D, and then the up, down, left, right arrows as well. That's so we can control with both. If you want to customize this, you can. You could select these, and you could get rid of the arrow keys if you wanted to. You could get rid of the WASD if you wanted to. In another video, we'll talk more about how the input system works, but all of these settings are totally fine as they are, so we're not really going to change them at all, but I do think it's helpful to look at some of these values and see what's different. Like for the look one, we have the right stick of the gamepad and the delta of the pointer. What that means is it's how far the mouse moves every frame. So it keeps track of the same kind of data that moving the right stick on a gamepad would. We've got the attack button, which is by default set to the button west, so north, east, south, west, that's the left one, or the left button of a mouse. There's a few things here. Trigger of a joystick. Enter key on the keyboard is by default attack. If you want to change that, you can click where it says path here, click that, and then click listen and type in the new character you want it to be. So type in, for example, like it's listening for a button. It might not be working on my computer, but you can also just go into the actual input itself and then look for the special key. So for example, I can change it to space by clicking here. We can also look at the interact button. It's E or button north by default, and all the ones here. That's all we really want to see about that. But I wanted you to pay attention to something. Player has move, look, attack, interact, crouch, jump, previous, next, sprint. If I click on the player object and this player input component we added and click on events, you'll see there's two drop downs, one called player, one called UI. This matches our action maps. If we open the player drop down, we notice there's a bunch of these are called unity events. One for move, one for look, one for attack. These are one-to-one for each of our actions that we have. So what we want to do is we want to use the ones that are relevant for what we're doing. In this video, since we're doing top-down movement, the move is going to be relevant. We'll also touch on sprinting. Now that we have all the setup stuff kind of like out of the way, we're going to actually set up our script. So I'm going to go into our script, and what we want to do is we want to set up a function that can be received by an input. So under our void update, I'm going to create a public void called move. By default, it thinks we want on animator move. If I press parentheses, it's going to like fill it in for us, which is not what we want at all. So again, if I do that, I'm just going to press like the arrow key or whatever to make it ignore the prediction, and then add curly brackets afterwards. This is a function in C# or a method. Basically, you can put whatever code you want inside of the curly brackets, and it will happen based on a different condition. Again, in update, the condition is every single frame, and on start, the condition is only once at the very beginning of the game. What we're going to do is set up our move function so it only happens whenever we press the move button. Inside of these parentheses, we're going to type in input action dot callback context ctx. This gives our function an input. This input is a variable called ctx. It's storing a bunch of information about the input. I'll show you what kind of information it's storing. Ignore all this crazy stuff here. Some things it's storing is the time that you press the button. It's storing the duration, the amount of time you press the button for. It's storing the actual value, obviously. Like if you're pressing left or right on a gamepad, it's storing whether you press left or right. Or like maybe you were in the middle. There's a bunch of other stuff too that didn't really show. Like it's storing whether or not we performed the action this frame. It's performing, storing a bunch of other cool stuff. So what we're going to do is we have public void move, and then I'm going to make a public void run as well. And this is also going to have the code for the input action callback context. I just selected that, copy and pasted it. I recommend doing that whenever we're using repetitious code. There's no reason not to. It really just saves time. Do not hand type this every single time. If you want to practice your typing skills, go onto a typing website or something. Putting this stuff in should be copy and paste if it's already there. Really quick, inside the move function, I'm going to write a line of code that'll print a message so we can confirm whether this works or not before we write a bunch of code for it. You always want to test your code in steps. Don't write a whole like hours worth of code and test it at the very end. It's not a very good idea. In move here, I'm going to write debug.log to print our message. And then, so this is a function. It's called log, and it's part of the debug class. Every function has parentheses, and every line of code that does something in C# ends with a semicolon. Inside these parentheses, we can type our message. So here, I'm going to add quotation marks, and the message is going to be moved. I'm going to copy this line, paste it into the run function, and I'm going to say ran. So again, I'm going to go through these things kind of quick because I know that it's a YouTube video and you can always pause and slow down and stuff like that. So I'm going to switch back to Unity now. I don't want the video to be way too long. So we have the two functions, but we need to actually assign them to the player input component. So under events and player, we have the move, look, attack, interact, all this stuff here. I'm going to click the plus button under move and the plus button under sprint. And then the top-down movement script that we've already attached to our player, I'm going to drag it into this empty slot that says none object that was created. And then where it says no function, I'm going to change it to top-down movement move. You'll see these are the top, and it's under a label called dynamic callback context. That means it knows that these are set up for the input system. Now I'm going to scroll down and do the same thing for run, but using run instead of move. We're going to ignore all these other ones for now. I'm going to hope that this warning doesn't mean anything. Now clearly the character is not actually going to move because we didn't write any code that says to actually make them move yet. We just have this little debug, and I want to see if it'll say anything. Right now we have the project window open. I'm going to click on the console window, which shows us all our messages. And whenever I press the button, you'll see that it says moved. When I let go of the button, it also says moved. The run button was it R or was it shift? It was shift, yeah. So notice that it only runs the code when I press and release the button. That's really important to know. Now we're actually ready to start writing the code and make it move. Movement is a physics-based thing, so we need a physics component on the player, which is, in this case, rigid body 2D. So we're going to click add component and type in rigid body 2D. And then this is not necessary, but 99% of the time you need this next part, which is collision. So we're going to click add component and type in box collider 2D. Our player now has a few components. Our player has the transform component, which keeps track of its position, rotation, and scale. It has the sprite renderer component, which keeps track of its color, its sprite, and a bunch of other things. It has the top-down movement component that we created and doesn't really do anything yet. It has the player input component that's reading all the inputs from our controller and sending out events to different scripts when they are executed. It has a rigid body 2D component that adds physics, and a box collider 2D component that adds collision. Before we do anything else, I'm going to go to the rigid body component, and right now the gravity scale is set to 1. I'm going to set it to 0 instead, because this is a top-down game. The player should not fall down with gravity. I'm also control S-ing to save every few minutes. Very good habit to get into. Back into our script. Let's actually write code that's going to make the player move. In the move function here, all I want to do is instead of debug log moved, we're going to write code that's basically going to access our rigid body component. The key, the whole fundamental thing of Unity is knowing how to access other components and getting their data or functions. For example, this script moves. So to do so, we need to access our rigid body because that's the component that is physics related that we need to access. So to get the rigid body, what you do is you type in get component and then angle brackets, rigid body 2D. This is going to get the rigid body component. This is a function, so it ends in parentheses, but we're not done yet, so we're not going to add semicolon. After the parentheses, we're going to type in dot linear velocity, and then we're going to say equals ctx dot read value vector 2. What this is going to do is it's going to say whatever you were doing, however you got this input, we're going to try and convert it to have an x and a y. That's what a vector 2 is. It's an x and a y value, kind of like on a coordinate grid. In this case, the input is controlled with the WASD keys, the arrow keys, or the stick of a gamepad, which means that x is how far along the left and right you are, or A and D, and the y is how far along up and down you are, or W and S. Let's see what this does. It's not quite going to work. You're going to see something. So I press the button, player moves. Oh, maybe it does just work. Okay, I'll explain why it works. So the player has settings here in the rigid body that does things like we can basically add linear drag and stuff like that. If I set linear damping high, what that means is if I apply physics, it's going to have like a drag, like basically an air resistance to where it'll automatically slow down. If I move my guy around and let go of the buttons, this just works perfectly. But I want to explain why I didn't think it was going to work. Because this function only runs when you start the input and when you release the input, which means that linear drag normally gets applied immediately after you start moving, because it doesn't happen every single frame. Like if I start moving, a frame later, this line of code that we just wrote is not going to keep running. It only ran the first time you press the button, and then we release the button. So if you had linear drag, this would get kind of messed up. But this works, so we're not really going to touch it. Except we are, because the run function. But before we go on to the run function, I want to address a couple things. One, our player was very, very slow. And two, what if our character does not have a rigid body? What happens if we do not have a rigid body 2D? Let's answer that one first. If I play the game, you'll notice that nothing happens yet because we haven't ran the function yet. But as soon as I try, we get an error in the console. We get a bunch of them. It says, there is no rigid body 2D attached to the player game object, but a script is trying to access it. This is a missing component exception. If you're trying to access a component that does not exist on the game object, it's going to freak out. So how do we fix this? Well, one, make sure you have a rigid body to your character. But two, you can write a little line above your script title here on this like little empty line here. Just press enter and type in square brackets, require component, type of, and then the name of your component in parentheses. This will mean that this object, like to Unity, cannot legally have no rigid body. If I go back to Unity now and try to remove the rigid body like earlier, now it gives me an error. I cannot remove it. This is very helpful when you're making scripts. Like if you ever use get component in a script, you should always also be using a require component, because you don't ever want to cause an error like that. It could be prevented. Next issue was the speed. Above our start function here, we're going to create what's called a variable. There's a bunch of different types of variables. We're going to look at a variable type called a float right now. A float allows you to create a number inside of Unity. So this number we're going to call speed, and we can give it a default value by saying equals and then some value like this. Every float has to end in the letter F. We have the float here. We haven't used it yet though. So to use it, what I'm going to do is this vector 2, I'm going to scale it by our speed, which will take the x and multiply it by speed, and the y multiply it by speed. So after the parentheses here, I'm going to say times speed to scale the vector. If we switch back to Unity, what we want is we want this float speed to be a setting. We want to be able to change it in the inspector. Like back to our rigid body, you'll see there's a few floats here. The mass, the linear damping, the angular damping, the gravity scale. These are all numbers we can change. We want to be able to do that with our speed float, but you'll notice that it's not there. That's because we just wrote float speed. By default, in C#, all fields or variables, in this case, are private, which means that they're basically invisible to everything except for this code here, including the Unity inspector, which we don't want. So to make it public, what we're going to do is, for the word float, type in the word public. And now Unity and other scripts can see this float. If I switch tabs back to Unity, now we'll see is a speed float here. Let's go ahead and play the game and see if our speed's 5 times faster. That's definitely a lot faster. We definitely move at a pretty much adequate pace now. You can always change the values while the game's running if you want to like really quickly iterate and check things out. But just know that when you stop the game, the values do get reset. So if you ever make important changes, don't do it while the game is running. And if you do, write them down before you stop the game. Okay, the script's almost done now. We actually don't need, actually there's a couple things we're gonna do now. This line here, line 23, this can be optimized. Because every time we move, we're grabbing the rigid body. And we're basically telling Unity, take the object and find its rigid body, and then do all this to it. And that's slow, because we can actually tell it beforehand, hey, this object has a rigid body. Let's remember that it has a rigid body, so we don't have to find it over and over again every time we run this line of code. So to do that, under our public float speed, we're going to make a private rigid body 2D RB2D. And then in our void start, we're going to say RB2D equals getComponent rigid body 2D. You'll see this getComponent rigid body 2D is very similar to the getComponent rigid body 2D we had earlier. In fact, the one we wrote earlier, we're going to replace it with RB2D, because based on what we wrote on line 13 here, RB2D is getComponent rigid body 2D. And we put this in the start function. So only on the first frame, what's going to happen is this variable here is going to remember that it's the rigid body. And then every time we use RB2D afterwards, it's our rigid body. So we're not getting it over and over and over again. We're storing it. We're caching it, if that makes sense. The code will run just the same. Also, this could happen a little bit earlier. Void start, as you see, it happens the first execution update after the mono behavior is created. So we can actually do it a little bit even earlier than that. I'm gonna get rid of this comment. If you do void awake, it's just even earlier than start. There's like not too big of a difference. For every script you write, all the void awakes will happen, and then all the void starts will happen. All of your get components should be in awake, because if you write code in start that relies on a get component from another script, you want to make sure that it actually happened. So all of your get component code should always be in awake. Okay, so last thing we're going to do is the run. What we need is our speed here actually has to be separated into 3 values. We need a walk speed, a run speed, and a current speed. The current speed is going to be set to the walk speed when we're walking and the run speed when we're running. So we're going to have walk speed, and then we're going to copy paste, call this one run speed, and then by default we'll set this one to 10. Remember, the settings you write here are only the defaults. Whatever is inside of Unity here is what's actually going to get applied. This is just what the default value will be when you add the script for the first time. So we have public float walk speed and public float run speed. All of our public values are these settings we want to be able to change in the inspector. This next float is our current speed. This is not a setting. This isn't something that the user can change inside of here, because this is just representing our current speed. So we're going to make this one private. Now, writing private float current speed like this and just writing float current speed are the exact same thing, but I always say it's better to be specific so that you don't run into any confusion later on. I'm also going to separate our private and public floats so that it's a little more clean. Now, our current speed is always going to have a default value of 0, and I'll show you that right now. Let's go into the game. I'm commenting this line of code out because it's a little broken right now since we didn't finish updating our code, but I do want to show you this before we do write our code. So we'll see walk speed, run speed are set up. If I play the game, we can't see current speed because we made it private, but we can actually view the value of private variables by clicking this ... button up here, and then clicking from, instead of normal, clicking debug. Now we can see our current speed and RB2D. Our RB2D is set to our player's rigid body 2D, and current speed is set to 0. We don't want that. We want current speed to start out at our walk speed. So let's fix that real quick. I'm going to stop the game, and I'm going to change the ... back to normal instead of debug. In our code here, we want the current speed to be set to walk speed immediately once we start the game. So we're going to put that in void awake right here. We're going to say current speed equals, it wants to say time, walk speed. This thing is awful right now. It wants to say walk speed times run speed. What does it think we're doing? Okay, so our current speed is now going to be walk speed when we start the game. Let's back to our move code here. In line 27, instead of rb2d.linear velocity equals this times speed, we're going to say current speed. And then this next line of code, we're going to go into our run function, and where it says debug.log ran, instead, we're going to use something called an if statement. An if statement lets us look at a condition, and if it's true, we can do one thing. And then we can write another statement called an else statement that says, if it's false, do this other thing. And the statement we're going to look at is, did we press the run button or did we release it? So to do that, inside of our public void run, we're going to say if, and then ctx.read value, and then angle brackets, we're going to say float. It's a little confusing. The float value is going to be 0 if we release it, and 1 if we press it. So I'm going to do 2 equal signs and a 1 there. What this is saying is, so it says 1. If the value of our button is 1, that means we pressed it. I'm going to write a little comment here to remind us. I'm going to write 2 slashes and write the word pressed. 2 slashes let you create a comment on this line in C#. That means that humans can read this code, but it won't break the machine. Like, if I got rid of these slashes here, C# would be wondering what the heck we wrote the word pressed for. But by putting these slashes here, it's basically invisible to the machine. So this code is going to happen when we press the button. And then we're going to add an else here. This is what's going to happen when we release the button. So I'm going to write another comment. Okay, let's actually write the code now. If we press the button, we want our current speed to be set to our run speed. If we release the button, we want our current speed to be set to our walk speed. Man, this IntelliCode is awful right now, just awful. I've never seen it this bad. Okay, so that should work, right? There's actually one reason it's not going to work, but let's just look into it first. Let's play the game, and before we do so, I'm going to change it back from normal mode to debug mode so we can see this current speed variable. Watch when I press shift, it changes to 10. When I release it, it changes to 5. This is exactly what we wanted. In fact, if I move around right now, if I stop and hold down shift and start moving again, we'll see it works perfectly fine. But the problem happens if I start moving and then press the button. You'll notice that even though current speed is changing, my actual speed is not. Now, why is this? This ties back to something I said earlier, and that is that this line of code only runs when I start moving and stop moving. It does not run every frame while I'm moving. What that means is that when I start moving, it applies my velocity, and then sometime later, if I press the run button, it's changing the speed. But I've already applied the velocity, so it's not being actually changed anymore. What we want is for this code to run every frame, because then when this value changes, the current speed value, it's going to change immediately on the frame that it changes, and not whenever we change our move like stick or whatever. So to do that, what we'd like to do is just move this code into update. But the problem is that this code relies on the value of ctx, which is only known inside of move. Notice that this is inside of moves parentheses. That means that only move knows about ctx. In this case, run also has a ctx that it knows about. But we can't just move the code over to update because there is nothing inside these parentheses. And you can't just move this part inside of update because Unity's update has to be empty. So the solution is we're going to make one more private variable that's going to keep track of our current, the last time we moved the stick, and we're going to update that inside move, and then actually update our velocity inside update. So to do that, we're going to say private vector2, we're going to call it movement. And then in our void move here, we're going to say movement equals, and then we're going to say ctx.readValue vector2. Again, we're cutting and pasting because I could have typed that all again, but I didn't need to, and I'm not going to need to use it again. So I cut it instead of copying it. Always copy and paste, Control C, Control V, or cut and paste, Control X, Control V. This line of code here is going to be moved into update. And then instead of the thing that I just got rid of, it looks weird now, between the equal sign and the asterisk, I'm going to type in movement. So now, whenever we change the movement with our stick, it's going to update this variable here. And then every frame, it's going to take whatever state that variable is in and whatever state our current speed is in, and it's going to use those to apply to our linear velocity. It's going to happen every frame. So as soon as either one of these changes, it's going to update our new velocity. So let's go in the code. Let's try it out, or the Unity, and try it out. I have some controllers here too I can test it out with. So I move my guy around with my gamepad. I'm going to press the run button while he's, if I can find it. Where's the run button? Oh, stick. Okay. So if I'm already moving and I press the stick, he starts running, or she starts running, wherever they. Back to the keyboard here. If I hold down the run button and then start moving, it works. If I'm already walking and I start running, it works. If I go into the debug mode again, you'll see how this works. The movement here has an X and a Y value. Again, the X is like horizontal left and right, and the Y is up, down, it's vertical. So you can see the value changes whenever I move. We'll see it also gets to be like this weird 0.7 thing when I move at an angle. That's just because how circles work. And with the stick, I can be a little more precise. I can move just a little bit in one direction. I can move a lot. I can be very precise, which is why I like the gamepads. So that's all for this video. You can now have a playable character that can move in a top-down environment and can run, and it works with the input system, which means that by default it works with all gamepads and keyboards and has future support for things like touchscreen and stuff like that. Hopefully this video was helpful. Go ahead and watch some of the other videos in this channel, because we've got things covering stats and interaction scripts and a bunch of stuff like that. The purpose of all these videos is very specific, like mechanics and features. So we're going to talk about these sort of things as opposed to generic things like the animator or tile maps or anything like that. Thanks for watching, and go ahead and watch another video.